Possible explanations for the tripping breakers include firstly, ground faults in the pumps. As suspected, it's possible that both pumps have a ground fault, which is causing the breakers to trip when the neutral and ground are bonded. Secondly, incorrect wiring at the pull box. Ensure that the line 1, line 2, neutral, and ground wires are correctly connected at the pull box. Verify that the ground wire is properly connected to the ground bus and that the neutral wire is isolated from the ground. Thirdly, improper bonding at the shed panel. Check the bonding at the shed panel to ensure that the ground bus is properly connected to the enclosure and that there are no other ungrounded conductors connected to the ground bus. Fourthly, equipment installation failure. Inspect the wiring, insulation, and connections for any damage or insulation failure that could be creating a path between neutral and ground. Fifthly, inductive coupling. In underground installations, inductive coupling between power lines and other conductors can induce a voltage on the ground wire. This can create a current flow between the ground wire and the ground bus, even if there is no ground fault. Verify that the underground conduit is properly bonded to the ground rod at both ends to minimize inductive coupling. Sixthly, accidental bonding. Check for any accidental bonding between the neutral and ground wires along the circuit run. This could occur through loose connections, damaged insulation, or improper installation. Troubleshooting steps include 1. Measure the voltage between the buried equipment grounding wire and the equipment grounding bus in the box using a voltmeter. If there is a significant voltage present, it may indicate a ground fault or improper grounding. 2. Temporarily disconnect the ground wire at the pull box and see if the breakers still trip. If the breakers stop tripping, this would confirm the presence of a ground fault in the pumps. 3. Use a ground fault tester or megometer to test the pumps for ground faults. If a ground fault is detected, the pumps will need to be repaired or replaced. 4. Check the wiring at the pull box. Verify that the wires are correctly connected and that the neutral wire is isolated from the ground bus. 5. Check the bonding at the shed panel. Ensure that the ground bus is properly connected to the enclosure and that there are no other ungrounded conductors connected to the ground bus. When dealing with electrical issues, especially near water, safety is paramount. Always ensure the power is disconnected before working on any electrical components. If you are not comfortable or familiar with electrical work, consult a qualified electrician. Now let's delve deeper into each of these possible explanations and troubleshooting steps. Firstly, let's explore the possibility of ground faults in the pumps. A ground fault occurs when there's an unintended path for current to flow from a live conductor to ground. This can happen due to damaged insulation, moisture intrusion, or component failure within the pump. When the neutral and ground are bonded, this ground fault creates a low resistance path for current, causing a large amount of current to flow, which in turn trips the breaker. To test for a ground fault, you can use a megometer, also known as a megger. This device applies a high DC voltage to the motor windings and measures the resistance between the windings and the motor frame or ground. A lower resistance reading indicates a ground fault. Another method is to use a ground fault tester, which can detect even small ground faults that a standard multimeter might miss. It's crucial to isolate each pump during testing to determine if one or both are faulty. Secondly, let's examine the wiring at the pull box. Incorrect wiring is a common cause of electrical problems. Carefully inspect the connections of the line 1, line 2, neutral, and ground wires at the pull box. Ensure that each wire is connected to the correct terminal and that all connections are tight and secure. The ground wire should be connected to the equipment grounding bus, which is typically a metal bar bonded to the enclosure. The neutral wire must be isolated from the ground bus at this point, as it's a separately derived system. If the neutral and ground are inadvertently connected at the pull box, it can create a parallel path for current, leading to nuisance tripping of the breaker. Use a multimeter to verify the voltage between each line and ground, and between neutral and ground. You should see approximately 120 volts from line 1 to ground and line 2 to ground, 230 volts between line 1 and line 2, and close to 0 volts between neutral and ground. Thirdly, improper bonding at the shed panel can also cause problems. The shed panel should have a main bonding jumper that connects the equipment grounding bus to the enclosure. This ensures that the enclosure is at the same potential as ground, reducing the risk of electric shock. Check that this bonding jumper is present and properly connected. Also, verify that there are no other ungrounded conductors connected to the ground bus. All ground should be connected to the ground bus, and all neutral should be connected to the neutral bus, which should be isolated from the ground bus at this point. Fourthly, equipment insulation failure can create a path for current to flow where it shouldn't. Over time, the insulation on wires and components can degrade due to heat, moisture, or physical damage. This can lead to leakage current between conductors or from a conductor to ground. Carefully inspect the wiring for any signs of damage, such as cracks, cuts, or discoloration. Pay particular attention to areas where wires pass through conduit or are exposed to the elements. Use a megometer to test the insulation resistance of the wiring. A low resistance reading indicates insulation failure. Fifthly, inductive coupling can induce a voltage on the ground wire, especially in underground installations. This phenomenon occurs when the magnetic field from a nearby energized conductor induces a voltage in the ground wire. The amount of voltage induced depends on the proximity of the conductors, the length of the run, and the frequency of the current. To minimize inductive coupling, ensure that the underground conduit is properly bonded to a ground rod at both ends. This provides a low impedance path for the induced current to flow back to the source, reducing the voltage on the ground wire. You can also use shielded cable or run the conductors in separate conduits to reduce inductive coupling. Sixthly, accidental bonding between the neutral and ground wires along the circuit run can create a parallel path for current, leading to nuisance tripping of the breaker. This can occur through loose connections, damaged insulation, or improper installation. Carefully inspect the wiring for any signs of accidental bonding. Use a multimeter to check the resistance between the neutral and ground wires. A lower resistance reading indicates a possible accidental bond. Now let's move on to the troubleshooting steps in more detail. Firstly, measuring the voltage between the buried equipment grounding wire and the equipment grounding bus in the box can provide valuable clues about the source of the problem. With the power on, use a voltmeter to measure the voltage between the buried equipment grounding wire and the equipment grounding bus in the box. A voltage reading close to 0 volts indicates a good ground connection. A significant voltage, say above 1 volt, may indicate a ground fault or improper grounding. The presence of voltage suggests that current is flowing through the ground wire, which should only happen during a ground fault. Secondly, temporarily disconnecting the ground wire at the pull box can help isolate the problem. With the power off, disconnect the ground wire at the pull box. Then turn the power back on and see if the breakers still trip. If the breakers stop tripping, this would confirm the presence of a ground fault in the pumps or the wiring between the shed panel and the pull box. However, be aware that disconnecting the ground wire removes the safety protection against electric shock, so the step should only be performed briefly and with extreme caution. Thirdly, using a ground fault tester or megometer to test the pumps for ground faults is a more definitive way to determine if the pumps are faulty. A ground fault tester applies a small current to the pump and measures the leakage current to ground. If the leakage current exceeds a certain threshold, the tester will indicate a ground fault. A megometer, as mentioned earlier, measures the insulation resistance between the motor windings and the motor frame or ground. A lower resistance reading indicates a ground fault. If a ground fault is detected, the pumps will need to be repaired or replaced. Fourthly, checking the wiring at the pull box is a crucial step in the troubleshooting process. As mentioned earlier, carefully inspect the connections of the line 1, line 2, neutral, and ground wires at the pull box. Ensure that each wire is connected to the correct terminal and that all connections are tight and secure. Verify that the neutral wire is isolated from the ground bus. Use a multimeter to verify the voltage between each line and ground, and between neutral and ground. Fifthly, checking the bonding at the shed panel is also important. Ensure that the ground bus is properly connected to the enclosure and that there are no other ungrounded conductors connected to the ground bus. Verify that the main bonding jumper is present and properly connected. All ground should be connected to the ground bus, and all neutral should be connected to the neutral bus, which should be isolated from the ground bus at this point. In addition to these specific steps, there are some general tips that can help with troubleshooting electrical problems. Always start by disconnecting the power before working on any electrical components. Use a reliable multimeter to take voltage and resistance measurements. Label all wires before disconnecting them to avoid confusion during reassembly. Take pictures of the wiring before making any changes. Keep a detailed record of all tests and measurements. If you are not comfortable or familiar with electrical work, consult a qualified electrician. Remember that electricity can be dangerous, and it's always better to be safe than sorry. Finally, consider the impact of the aluminum wiring. Aluminum wiring was used in some homes in the past, and it can present unique challenges. Aluminum is more prone to oxidation than copper, and this oxidation can create a high resistance connection, leading to overheating and potential fire hazards. If you have aluminum wiring, it's important to use special connectors that are designed for use with aluminum. These connectors are typically filled with an antioxidant compound that prevents oxidation. You should also periodically inspect the connections for signs of corrosion or overheating. In summary, troubleshooting electrical problems with pool pumps requires a systematic approach. Start by identifying the possible causes, such as ground faults, wiring errors, and inductive coupling. Then follow the troubleshooting steps to isolate the problem. Always prioritize safety and consult a qualified electrician if you are not comfortable or familiar with electrical work. Also, when working with aluminum wiring, pay special attention because it is more prone to oxidation than copper. By following these guidelines, you can effectively diagnose and resolve electrical problems with pool pumps.